Good morning. We will start session 4 on chapter acid, bases and salt. Till now we have completed what are acids, that is physical properties of acids and physical properties of base. How do we classify acids based on their sources, ionization power and their concentration. Similarly, we also understood about how do we classify base based on their concentration and ionization strength. We also understood about indicators. What are indicators? We have natural indicators, synthetic indicators and olfactory indicators. How do acids and bases react to these indicators by showing either change in color or smell? We understood that till there in our previous classes. So now in today's class, we will start with the chemical properties of acids. So when we start with chemical properties of acid, we will first understand what happens when acid reacts with metal. It reacts with metal carbonate, metal bicarbonate and so on. Let's see the reaction. Reaction of acid with metals. Metal react with acid to give salt and hydrogen. Now here what you have to remember is whenever an acid is reacting with a metal, what are the byproducts formed? If you remember that metal is reacting with acid, which will always give a respective metal salt and hydrogen gases liberated. You need not even by heart the equations here. You can take any metal, you can take any acid, make them react. The respective salt should be formed and hydrogen gas is liberated. Here you can practice the equation only by writing it and by practicing number of equations. If you read it, equations cannot be practiced nor it be remembered. So metal, I have written only one or two examples for each of the properties. For example, with metals, metal carbonate, with metal hydrogen carbonate, I have only taken one or two examples. Remaining examples you can as well get in the book. So metal reacts with acid to give its respective metal salt and hydrogen gases liberated. Sodium reacts with hydrochloric acid to give sodium chloride and hydrogen gases liberated. Similarly, one more equation. Zinc reacting with sulfuric acid gives you salt, that is zinc sulfate, and hydrogen gases liberated. So whenever a metal is reacting with the acid, it is forming its respective salt and hydrogen gases liberated. If you just recapitulate in our chemical equation chapter, we had already done this equation, but there we did not mention that it is a metal reacting with acid, right? But we understood about the hydrogen gas liberation, a type of test called as POC test, right? So what does this POC test tell us? When we conduct this experiment, the gas liberated is hydrogen. How do you check the presence of hydrogen? If you take a burning matchstick or a candle, near the mouth of the test tube, there is a pop sound heard. So that gives us the presence of hydrogen gas in the equation whenever metal is reacting with acid. A question is asked, determine the test or give the, how do you check the presence of hydrogen gas when a metal reacts with acid? You have to explain about POC test. How are the questions asked in this part? Give a reaction when a metal is reacting with the acid, or reactant is given Na plus Cl, complete the following reactions. So here you need not by heart anything, only if you remember metal and acid will give you salt and hydrogen. Yes? We'll move on to the second one, reaction of acid with metal carbonate. Now here, before we start with this chapter or before you start with equations, you should be very perfect in framing the compound equation or formula, that is carbonates, sulfate, or if I say sodium chloride, how to write sodium chloride, that you all should know first. Now I wrote here zinc sulfate, I should know how to write zinc sulfate. I have written sodium chloride, I should know how to write sodium chloride. See, balancing you can do it, but how to frame this, that you should be very perfect. If you are perfect in the first chapter, that is chemical equation, you will be perfect here in framing the equations and as well balancing them. So reaction of acid with metal carbonates. Metal carbonate react with acid to give salt, carbon dioxide and water. Did you observe one thing here? In all the reactions, salt is a common byproduct. Whenever a metal reacts with an acid, metal carbonate, metal bicarbonate, anything, salt is the byproduct, that is must and should, and there is a gas liberated with water. But salt is the byproduct in every reaction. Remember this, respective salt. Metal carbonate plus acid gives you salt, carbon dioxide and water. So metal carbonate, calcium is a metal, carbonate is CO3. So calcium carbonate reacts with sulfuric acid, gives you calcium sulfate plus carbon dioxide gas is released and water, right? So again I am telling you, I have written only one equation. Metal carbonate, any carbonate you can take. Sodium carbonate, how do you write sodium carbonate? Na2CO3. So this is metal carbonate, sodium carbonate reacting with hydrochloric acid, reacting with sulfuric acid. Make that react with a particular acid. So what it has to give you? Sodium sulfate plus carbon dioxide and water is a common byproduct here. Right? There is a test for carbon dioxide. We'll see that next. We'll first understand this. Reaction of acid with metal hydrogen carbonate. Metal carbonate is different from metal hydrogen carbonate. So metal hydrogen carbonate is also known as bicarbonate. So we all know sodium carbonate, sodium bicarbonate. You all know this? Yes. So metal hydrogen carbonate is also known as sodium bicarbonate. That means in sodium carbonate, one H is added extra, one hydrogen is added extra, which makes the word hydrogen carbonate in the respective metal. Now let's see what will happen. So metal hydrogen carbonate reacts with acid to give salt, carbon dioxide and water. The same reaction. Sodium hydrogen carbonate. Where do we use this sodium hydrogen carbonate? Or another name I use it as sodium bicarbonate, which is also known as baking soda. Where do we use it? We use it in all bakery products. We all know that. So sodium hydrogen carbonate or sodium bicarbonate react with hydrochloric acid to give NaCl. What is this? Common salt, carbon dioxide and water is released. So here carbon dioxide gas is released. Now the question arises here is, how do you check the presence of carbon dioxide, or how do you know that it has released carbon dioxide gas only? So test for carbon dioxide is, we pass the whatever gas is liberated in this reaction, carbon dioxide, that is passed through lime water. And when it is passed through lime water, the lime water turns milky. That is a test for carbon dioxide. POG test we understood here. How do we check the presence of carbon dioxide gas released here? By passing the carbon dioxide through lime water, where the lime water turns milky. What is lime water? What is a chemical name? What do we call lime water as? We have done this in the previous chapter. Calcium hydroxide is called as lime water. So just see here, test for carbon dioxide. When carbon dioxide is passed through lime water turns milky. That is carbon dioxide plus calcium hydroxide, which is known as lime water. It turns milky formation, and what is formed with that? Calcium carbonate is formed plus water. The aqueous form, right? So here this calcium carbonate is nothing but which is turned milky in nature, right? Now I should pass a amount of carbon dioxide so that it will turn milky, right? What if I pass too much of carbon dioxide to that? What if I pass too much of carbon dioxide to lime water? The milkiness will disappear. Why the milkiness will disappear? Because instead of forming calcium carbonate, it will form calcium hydrogen carbonate, which is soluble in water, since that milkiness color will disappear. So see how the question can come in this. How do you check the presence of carbon dioxide gas liberated in the given equation? Carbon dioxide is passed through lime water, which is nothing but calcium hydroxide, which turns milky, gives the formation of calcium carbonate, right? Another question. What happens if too much of carbon dioxide is passed through lime water? You have to write, when too much amount of carbon dioxide is passed through lime water, it turns the milkiness color will disappear because of the formation of calcium hydrogen carbonate, which is soluble in water. Yes, so this is the reaction of acid with metals, acid with metal carbonates, acids with metal hydrogen carbonates, and about carbon dioxide test. Now we'll go on to the few more reactions and we'll see what happens when acid will react with some more things. Now let's see what happens when further acid reacts on few more things. Acid reacts on marble or eggshell. Now what do you mean by marble or eggshell? They are nothing but metal carbonates. So marble or eggshell is nothing but calcium carbonate. So we all should remember that sometimes. See, the question can be asked, what is the action of acid on metal carbonate? Just now we completed. What is the action of acid on marble? It is nothing but metal carbonate. What is the action of acid on eggshell? It is nothing but metal carbonate. Which metal carbonate? Calcium carbonate. So, action of acid on marble or eggshell is nothing but calcium carbonate. Remember this, which is nothing but a metal carbonate. But they directly will not give you CaCO3. They will ask you in the form of marble and eggshell, which is nothing but a calcium carbonate. Let's see, acid on metal carbonate will give you what? Salt, carbon dioxide and water. Same reaction here. Calcium carbonate reacts with sulfuric acid to give calcium sulfate. Carbon dioxide gas is released plus water. Right? Clear about these things? Okay. We'll go to the next one, which is called as a neutralization reaction. Now, what do you mean by neutral? Now, in chemistry, about atoms and all, when we talk about neutral, that is nothing but same amount of positive and negative charges, right? It is neutral. Amount of negative and positive are same in that. Neutral stands for what? For nothing. So, nullifying something. So, here when we talk about neutralization reaction, it is about nullifying something or equalizing something. That is, I have an acid, if I add equal amount of base to it, it neutralizes, right? So, an acid neutralizes a base when they react with each other. So, reaction of an acid and base to form salt and water is called as a neutralization reaction. So, acid and base is neutralized. Neutralized in the sense they nullify each other. Acid and base will give you, when acid reacts with base, it gives you salt and water, which is nothing but a neutralization reaction, which we have to remember. Sulfuric acid plus sodium hydroxide. Sulfuric acid is a acid. Sodium hydroxide is a base. So, acid and base is reacting to give salt and water. Remember one thing, what I had told you, salt is the common byproduct whenever acid is reacting with something. So, it is giving its respective salt, sodium sulfate plus water. Equation is balanced. One more I have given, hydrochloric acid, it's an acid. Calcium hydroxide, it's a base. So, these two will react, they neutralize to give salt and water. Calcium chloride is a salt and it is giving water, which is nothing but a neutralization reaction. What question you can expect in this? What is neutralization reaction? Give an example. Equation is given. Identify the type of reaction can be asked, right? So you should be very careful by looking at the reaction. So in the first reaction, whenever acid is reacting with metal, what is formed? Only if salt and hydrogen is formed, it is a type acid is reacting with a metal. Salt, carbon dioxide and water is formed, it is reacting with a metal carbonate or metal hydrogen carbonate. Only salt and water if it is giving, then it is a neutralization reaction. That is how you have to remember this, right? We'll go on to the next one. Reaction of acids with metal oxide. Whenever acid reacts with metal oxide, it also forms a neutralization reaction. How is it? It is reacting with metal oxide. Then how is it forming a neutralization reaction? Under what case a neutralization reaction is formed? It is only formed when acid is reacting with a base. That means metal oxide should be base, right? Yes. All metal oxides are basic in nature. That means whenever I react an acid with a metal oxide, I get salt and water. What is this reaction of getting salt and water? Neutralization reaction. But how is it possible? It is reacting with a metal oxide. Why? Metal oxides are basic in nature. So, if I take sulfuric acid and if I take a metal oxide, it will give me zinc sulfate, salt and water. Now, similarly, just imagine that if I take zinc oxide and I mix that in water, I get zinc hydroxide. What is it? What is zinc hydroxide? It is nothing but a base. So remember, metal oxides are basic in nature. So if they are basic in nature, acid reacting with metal oxide will give you salt and water, which is nothing but a neutralization reaction. Yes, so these are the reactions which are given in your book. There's a last reaction where I have given with a star mark. That's only because this reaction is not mentioned in the book, but sometimes this is asked in 1 mark MCQs. How is it asked is, name the gas liberated which smells as a rotten egg, right? Though we don't study that in the syllabus, but sometimes the questions are asked on that. So I've just given that 1 point. You can make a note as well. Only this 7th one, wherein it's not mentioned in your book. Reaction of metal sulfide with acid. So metal sulfide, I have taken iron sulfide here. Any metal sulfide. Any metal sulfide reacting with acid will give you what? Salt plus a respective gas will be liberated. But that gas will smell like a rotten egg. So if you don't know what is a rotten egg smell, if you have eggs at home, once they get rotten, you try to smell that, you will come to know what is the smell. So I have taken a metal, iron sulfide reacting with sulfuric acid. What is formed here? Salt is formed. And which type of gas is formed? Hydrogen sulfide is formed. So how you can write the reaction here? I'll just write it is metal, M I have written for metal, plus acid or no, metal sulfide. I'll just write MS here. MS stands for metal sulfide plus acid. What is formed? Salt is formed plus hydrogen sulfide gas is liberated. So a metal sulfide plus acid will give you its respective salt plus hydrogen sulfide gas is liberated. The smell of hydrogen sulfide gas is like a rotten egg. So here basically the equation is not asked. Which is a gas which smells like a rotten egg is usually asked. Right? So there we complete the chemical reactions of acid with its respective metal carbonates, bicarbonates, then neutralization reaction and with metal oxides. Now, since we understood about the neutralization reaction, let us just analyze few practical applications of neutralization reaction. That is nothing but acid with base is getting neutralized. It is as simple as that. What do we do when we get acidity? We take an antacid, right? So, in what form? In a liquid form, in a capsule form, in a tablet form, or in just something like that, a syrup form. If you all know, we consume sometimes Digene tablets, or we have a Digene syrup, or we also take Eno, right? A basic antacid, what we usually have it at our home. Severe, then we go to a doctor. So acidity is neutralized by a antacid. See, acid and a base, it neutralizes. Next, sting of a bee or an ant, we all already know that they contain formic acid. Suddenly if a bee sting or if there is an ant sting, what you do as a home remedy, you just take some baking powder and you apply on that so that inflammation burning will stop. That's only because sting of a bee which contains a type of a acid, that is formic acid, it is neutralized by a baking soda. Baking soda is sodium bicarbonate, which is nothing but a base. Next, sting of a wasp. Wasp, though it comes in a type of an insect, but the sting of a wasp has a base content in it, that is alkali, right? So bases are also corrosive, not only acids. So that is neutralized by an acid. That means if you have vinegar at home, you can apply vinegar to it, it neutralizes, right? So these are some practical applications. What we do it at our home unknowingly sometimes because it causes neutralization reaction. So in today's class, we completed what are the chemical properties of acid along with the neutralization reaction as well as some practical applications. Now similarly in our next class, that is tomorrow's class, we will be studying about chemical properties of base. So in today's class, whatever we have studied, if you have any doubts in them, you can call on the same day of the video set. Thank you.